Okay, I think we're going to go ahead and get started today. Just want to say hello and welcome to today's event on Microsoft Azure, or more specifically entitled, Cloud Expert Spotlight the 10 Top Workloads for Azure. My name is Scott Mitzelfeld. I'll be your moderator today, and I want to personally thank everyone for taking time out of your day to join us. On behalf of responsiveX and our sponsor, Microsoft, I'd like to welcome you. Before I hand this over to our speaker today, Eric Boyd, I'd like to get a few simple just housekeeping items out of the way. Let's talk about social media for a sec. We're definitely tapping into social media during this webcast. We're using hashtag Azure Top 10, all is one word. Feel free to post any tidbits you learned today, as we'd love to hear from you. Let's talk about questions and answer session. Let me say that we'll have an opportunity for questions during Eric's presentation near the end. I know Eric has a full agenda, and we'll get to as many questions as we can. There is a planned time, about 10-15 minutes near the end, for Q&A as well. If we don't get to all the questions in the time we have, then we will work to respond outside of this event as well, even if we run a little late today. And you can ask questions just by using the chat box on your screen. I do want to just take care of an answer to one common question, and that surfaces pretty often, and that's just, will this presentation be available after the webcast today? And the answer is it will. It will be available on demand, and we'll usually get that this session posted about 24 hours after the event today. You can find it in one of three locations. The first one would be on the responsiveX website, which is www.responsiveX.com, on their YouTube channel, which is youtube.com/responsiveX, which is showing on the slide now. The third way would be on their Facebook page, just a simple responsiveX search. It's one word, responsiveX. All right. Today's presentation focuses on a really important topic. When helping companies innovate or increase agility, save money, and accelerate time to market, Chicago-based cloud experts, responsiveX, have encountered a common theme and desire from customers to integrate cloud platforms and technologies into their solutions. So out of these experiences with customers and through many conversations with different companies adopting cloud technologies, responsiveX has compiled the 10 top business scenarios and technology workloads that organizations are running in the cloud with Microsoft Azure, formerly Windows Azure. That name just changed in the last month or so. During today's webcast, technology expert Eric Boyd from Chicago-based consultants responsiveX is about to unveil for us these 10 most common workloads that you could be running in the cloud and you might not be now. This webcast will get your gears turning to help you generate new ideas, while giving you the knowledge you need to evaluate your current workloads and upcoming projects, and help you maximize your technology investment. If you're not familiar with Eric, he is the founder and CEO of responsiveX, he's also just one of a select few handpicked Windows Azure MVPs, and a regular speaker at national conferences, regional code camps, and local user groups. As a result of his passion for technology, apps, and cloud services, he founded responsiveX, where he helps customers with management and consulting to build out outstanding web, mobile, and client experiences, often using the cloud. Simply put, Eric lives in the cloud. He launched his technology career almost 2 decades ago with a web development startup and has served in multiple roles since, including developer, consultant, technology executive, and business owner. You can find Eric in a couple locations. You can find him blogging at ericdboyd.com, and you can find him active on Twitter at twitter.com/ericdboyd. Having said that, and without further ado, let me turn the presentation over to Eric. Eric.
Thank you so much, Scott. Thanks for that great intro. So as Scott said, I live in the cloud. And so this is pretty much what I do all day, every day, and that's not an overstatement or some crazy kind of cliche. That's really the case. And so after I get done with this webcast today, I'll be slinging more code in Azure. So very deep in Azure, and I've been working with Azure since about 2008 now. So many years in Azure, even before it was really well known and in production. So a little bit about responsiveX in our company. What we do is we help customers, I think Scott mentioned this, basically build applications on Azure, migrate workloads to Azure. As a result of our experiences with Azure over many years now, we have just seen a number of common trends and workloads that companies are gaining huge advantage from running in the cloud. And so our time together today, I'm going to give you an overview of the cloud in Microsoft Azure very quickly. I see there was a handful of folks in this webcast that are not familiar with Azure or not using Azure, and so quick overview of that, and then we're going to dive right into these top 10 workloads for Azure. I'm going to point you to some additional resources that can help you get started, things like pricing calculators and that sort of thing. And then I'm going to do my best to leave a good chunk of time for questions at the end, because what I want this to be is an interactive session so that you're able to get some answers to some questions that you have. And if we can't answer them interactively during this webcast, we'll definitely take those offline and help you the best we can. So with that, what is the cloud? Very simply put, it's an approach to computing that's about scale. And it's about scale not just in the terms of performance and capacity, but also global reach, and also connecting to platforms that are very diverse. And so we all have a diverse set of smartphones, for example. We have things like connected devices in our homes. That's the Internet of Things is becoming more and more popular with things like Nest and all sorts of Internet-connected devices. And so the cloud is really all about how do I build or use an environment for my computing needs at scale, both from a performance perspective and from a broad coverage and a global reach perspective. And so at the core, Azure provides some basic fundamental services. Compute, many flavors of compute, things like the origins of Azure, which is cloud services, which is a PaaS offering that enables you to simplify deployment to Azure, scale massively, things like websites, anything you could run basically in Windows, you could run in cloud services. Virtual machines, and virtual machines are a little radical in the sense that there's Linux offerings in Microsoft Azure. And so that's often a shock for folks. It's not just Windows, but I can run basically anything I can stuff into a VHD, which is Hyper-V's virtual hard drive format. Anything I can run in a VHD, I can run in an Azure virtual machine. Things like websites, which is another platform offering to just run IIS websites. I could run Node.js applications. I could run my traditional ASP.NET applications. I could run PHP as well, which is also a little radical for Microsoft and a Microsoft service at first glance. Then there are services around storage. So storage services for storing large files, NoSQL storage options for storing entities and key value pairs. There's queuing services as well. And there's relational database services as well. So Microsoft Azure SQL Database is the relational data store in Microsoft Azure that's a platform service offering. So at the core, this is what we're really looking at: compute, storage, relational data. There's more services in this, and I'll briefly talk about that in just a second. On top of just the load and the ability to scale within a data center, the other thing that Microsoft Azure provides is a global footprint of data centers. And what I mean by that is you have the option of using a data center in the U.S. or many data centers in the U.S. We have 4 today in the U.S. There are options to use data centers in Europe, Asia. There are data centers that aren't on this map that are available for us today. So the blue dots represent data centers. The green dots represent content delivery network nodes. And there's also a data center today in Brazil. There are 2 data centers in Japan now that are not shown on this map. And there's also data centers mainly in China, inside the Great Firewall of China. So there are a lot of options for you to not just choose a data center to use somewhere around the world, but you can also use multiple data centers and route traffic to the data center closest to your users. In addition to the fundamental options of compute, storage, and databases, there are a lot of application components that you can plug in, subscribe to, and stitch together to build your applications. So things like caching services, messaging services, the content delivery network that I briefly touched on that's global around the world to help deliver content close to your users, all of those things you can tap into and stitch together to build your own applications. And so when we think about Windows Azure or Microsoft Azure now as a platform, what we're really thinking about is how do we, as developers and technologists, how do we stitch together some services into our applications and not have to build all of those things ourselves. So generalized common services, truly a platform. For today's conversation, what we want to do is take and build upon that. And we're not going to dive deep. We have 10 scenarios that I want to walk through today rather quickly. And so we're not going to dive deep into any of these scenarios. The purpose is really to get your gears turning. Scott mentioned that in his intro. We want to get you thinking about what is possible in Azure and how Azure can help your business and how it can help you as developers and IT pros accelerate some things and reduce some burdens that you have when working with data center compute and hardware and infrastructure. So that's our purpose today. And so we're going to unveil kind of years of experience and research from working with customers, and then we'll provide you a way at the end to get a hold of a nice data sheet as well that will, you can post it on your wall or something like that. You can a quick reference back to these scenarios. So the first and the most common scenario we run into is dev test. And it's super simple at the end of the day. I used to be a tech exec for a large global transport company, managing a team of developers, and the common request would be complex environments. We're building line of business applications that have multiple tiers involved, from things like terminal server boxes to SQL servers to application servers and web servers. And it's complex and difficult to set up those environments to do development and testing. And so it takes a long time to do that. The hardware is expensive, and it's a capital expense. And so if you are to go to your leadership and request expensive hardware for development and testing, it's unlikely that that's going to be an easy conversation or a quick conversation, because it's just not in the budgets. It's a big expense, and oftentimes the value is not kind of well understood. Capacity is limited, so because of that, our data centers are generally used for production workloads, and that capacity is limited, and it's difficult for us to get access to good hardware for setting up these environments. And so often, if we do get hardware, it's some hand-me-down hardware that's not representative of a real environment, and beyond that, it's sluggish, and it just takes us a lot of time to do what we really need to do. And the last big thing that we see is isolation. And so if you are a developer or a tester and you need to set up your own sandbox to test some feature, and you don't want other developers or testers colliding with you and using that same environment, that's really difficult because, again, it's just expensive, it's long setup times, that sort of thing. And so in Azure, it's very simple. I don't want to oversimplify it, because while it is simple and easy to just go get access to Azure and spin up VMs, and at the end I will break out into the Azure Management Portal for those who have not seen it and show you how quick and easy it can be to just set up services in Azure. But because of that, it's accessible, and it's not a capital expense. It's not investment that we have to plan for in our budgets in a big way. Depending on the size of your organization, it may be a large operational expense that you have to plan for, but it's as simple as swiping a credit card. And for most developers in large organizations today have Microsoft subscriptions to MSDN for Visual Studio and other tools, and as a result, you get Azure time for free. And most people don't understand this, or they don't have their subscriptions activated. And so using your MSDN subscription for Azure is a huge advantage in this dev test scenario. And so your MSDN subscription, if it's an ultimate subscription, you get $150 every month to spend in Windows Azure services. And that's per developer, per MSDN subscription. And so that's $150 doesn't seem like a lot, but the MSDN rates are also cheaper. It's a special dev test rate that's cheaper than the normal production rates for Azure. And so you can get started, spin up VMs in your Azure subscription with MSDN, and it doesn't even cost anything for you. It's just included. And one thing I do want to add is those MSDN subscriptions, those Azure subscriptions, it's a use it or lose it sort of thing. It's not like rolling over minutes on your cell phone or anything like that month after month. It's you use it this month, and it's gone at the end of the month. So if you don't use it, it's gone. So you do, if you have these scenarios, it can just simplify your world, and you should use it because it's going to go away if you don't. So in addition to that, I want to flash up this awesome graphic that our team has put together here at responsiveX. One of the things, the way we like to think about this is dev tests can be a massive sinkhole, both just time and money. It just sucks kind of the life out of us as developers, and the IT pros really hate us asking over and over again for more hardware and for them to provision hardware and VMs for us. And so we have an event coming up in Chicago, Milwaukee, and Downers Grove, and there's a bit.ly there. It's Dev Test Tour coming up at the end of May and the 1st of June, specifically targeted at dev test and production workloads and how you can get started. And it'll be a lot deeper than today's talk about dev test. So if you are in the Chicago, Milwaukee, or Downers Grove area, we have a lunch and learn. If you're in Milwaukee, it's a really fun lunch and learn because it's at Miller Park, and right now the Brewers are just killing the baseball this year, so it's a fun time to go to Miller Park. All right, number 2, IaaS app migrations. So in addition to dev test, what we see is a lot of tier 2 or tier 3 workloads. And when I say tier 2 or tier 3 workloads, it doesn't have to be tier 2 and tier 3, but it's an easy way to get started. Stuff that's not betting the company on, stuff that's not mission critical. Maybe it's something as simple as something that runs once a month. And so I met with a customer this week that has that scenario where they have a number of batch processes that run one day a month, but they have hardware dedicated in their data centers for those batch processes. And so consolidation is a good first step in your own data center, but reclaiming that hardware to use for tier 1 scenarios and tier 1 workloads makes a lot of sense if you can just push these other applications off into Azure and pay for consumption. So that's an important thing to remember and understand with Azure is you're not buying servers up front. You're not paying for servers up front. You pay for the consumption. You pay for the usage. And it started that we paid for clock hours. And so if you had a service running at 11:50 and a service that ran from 11:50 to 12:10, for example, we would pay for 2 hours because it hit the 11 o'clock and the 12 o'clock hour. Things have radically evolved in Azure these days, and we now pay prorated rates per minute. And so if we needed to run a service for a few minutes, we would pay for those prorated compute rates by the minute. So it's pretty radical kind of where we're going in terms of paying for that capacity. So IaaS is infrastructure as a service for those that are not familiar with that acronym. We have a lot of acronyms and buzzwords in the cloud world. And infrastructure as a service is just like it sounds. We're getting access to raw infrastructure resources and compute resources, so VMs and compute, storage, SQL databases, SQL Server running in a VM, that kind of thing. And so it's very easy for us to, what I would like to call lift and shift those workloads into Azure. So if you have these workloads today running in a virtualized environment, and if it's running in Hyper-V, it's super easy. That same VHD format is the exact same VHD format that runs in Azure. And so you can take your VHD, copy it out to Azure, if you will. And so copy and paste your VHD basically out to Azure Storage and boot that thing up in Azure. And you can come back the other way as well if at some point you decide running in Azure doesn't make sense anymore, or you also want to run it in your own data center as a business continuity or disaster recovery strategy. And so it's really nice, the Hyper-V format being interchangeable between Azure and Hyper-V on-premise. So it makes it very easy for us to just pick that up and move it to Azure. And so this is just a quick diagram of kind of how we think about IaaS app migrations, things like VMs and application and servers running in VMs out in Azure. And those VMs are run on Azure Storage, and one of the benefits of that compared to other providers is the way Azure Storage works is every time I save a piece of data to Azure Storage, it's highly available. It's stored 3 times in 3 separate copies. And so having that just out of the box gives me high availability and the RAID-like SAN functionality that I have on premise. The great news, we've talked about Hyper-V, but the technologies, we can manage those technologies, both Azure and on-premise data centers, with the same set of tooling. So things like System Center and Visual Studio I can use to manage my applications, whether they're on-premise or whether they're out in Azure. And last, in this diagram, we see this VPN connection. One of the great advantages with Azure is the virtual network capability, which is basically, think about it like a VPN tunnel that we can connect the Azure data center with our own on-premise data center. Now, why would you want to do that? It's unlikely that you will move everything out of your data center to Azure. I can tell you I've not seen that happen. We have one customer that's in the middle of that process right now of moving everything from their private data center, and it's a very large data center, to Azure, but that is a radical scenario. Generally, you have things on-premise in your data center and in Azure, and you need a way to bridge those. So hybrid cloud is the buzzword that gets thrown around here. And so something as simple as Active Directory. You may just want Active Directory running on-premise for authenticating your users. And so with Azure, I can bridge with a VPN tunnel using virtual networks, Azure and my on-premise data center, and allow Active Directory to still live on-premise while my application servers, SQL Server, is running out in Azure for my application. So this is a very common scenario that we see. Number 3, so we're not counting this down like a top 10 list with Letterman or anything like that. We're going to count it up and go from the common scenarios to the less common scenarios. So tiered storage. You may hear this referred to as cloud-backed storage or something like that. Basically what we're talking about is the fact that storage today in our own data center, we have lots and lots of storage equipment. We have sprawling storage equipment all over the place. Our data is growing rapidly. So I've heard Eric Schmidt quoted before talking about, and Eric Schmidt from Google talking about, up until early 2000s, all the data that we stored up until then, we're storing like every day or some radical period of time. And so our data growth is massive and sometimes even exponential. Our backup needs are growing as well because the data is growing. We are more and more expected to have just always on seamless business continuity and disaster recovery so that there's very little to zero downtime. And so storage is a challenging area for folks in the data center today. And it's just like servers and VMs. The capacity is limited. And so with Azure, we have a lot of options. I have one pictured here. This is one of my favorite options. But we do all sorts of stuff with storage. And you can just get raw access to storage via a REST API as well. But what I'm looking at right here is an on-premise SAN. And so there was a little company called StoreSimple. They're not really all that little, but Microsoft bought them a year or 2 ago. And what StoreSimple built and provided was a SAN appliance for your data center. But the thing that they did differently with their SAN is instead of just having all the disks and all the data stored in the data center, they had hot data stored on the SAN in the data center, and behind the scenes, cold data that was used less frequently, which we all have. We keep data around forever for various reasons, but very little of that data is generally accessed. And so what StoreSimple said is we understand that, and we tier that storage. And so we start out with things like SSDs, we move that data off to SAS drives, and eventually we move that out to Azure. And an Azure storage account, a single Azure storage account, has the maximum capacity of 200 terabytes. And so that really opens up our on-premise storage in a radical way, and it's passed through. So we just access the SAN, and if a piece of data is cold, the SAN device will go out to Azure, retrieve that, and pull it back for us, and we don't really care where that's stored. And so StoreSimple is a great example of tiered storage. Other vendors like Riverbed and Commvault and eVault and other vendors are also doing similar things for different workloads. StoreSimple is not a backup device, but other vendors provide that sort of backup device. StoreSimple is a great device for online workloads like SharePoint and SQL Server and that sort of thing. And we can get access to storage, again, in a raw format via REST APIs. And so, one of the things that I just helped a customer with is taking a large SQL Server database. So SQL data is very expensive. SQL Server is very expensive. It's difficult to scale that, and so that hardware used inappropriately or for the wrong kinds of data can be a big mistake. And so we just helped a customer shrink their databases by 90% by extracting chunks of data, just a few chunks of data, out to Windows Azure Storage, blob storage, and they're able to reclaim, without buying new SQL servers, reclaim a lot of SQL Server capacity. So tiered storage is a great way to use Azure and get started. So now we're getting into even cooler kind of application scenarios, and that's mobile. Mobile is hot. It's been hot for a while. The challenge with mobile, and I briefly mentioned this earlier, is we have diverse platforms, lots of diverse platforms. And so, the common ones that come to mind would be things like Apple, Android. There's Windows Phone somewhere in there. We have BlackBerry. We have Windows 8 now on tablets. There's plenty of platforms. There's HTML5 apps. There's hybrid apps using things like PhoneGap and Apache Cordova. And so this space is very diverse. The challenge with that is we have to write code on the back end for each platform. Now, not everything, but things like push notifications. Every time we adopt a different platform, we have a different set of technology or a different set of APIs, different authentication mechanisms that we have to use to send push notifications back to those devices. And tracking those devices is a little painful and that sort of thing. Also, scaling for load is not terribly easy, and maybe we didn't plan for our app going really viral. And so if we were to build something like Flappy Bird, and we didn't expect that sort of growth, and we had lots of cloud backend infrastructure or lots of APIs, for example, that's maybe not in the public cloud, we may not have been able to scale for that load. And so the great thing about using Azure in this scenario is we can instantly scale just by turning a dial. We can scale geographically as well. So I can put this in multiple data centers and route that traffic to the closest data center using services like Azure Traffic Manager. And when we're building mobile apps, we really are trying to focus on the user experience and the applications themselves, not the plumbing for things like the web APIs and for security and notifications. That's really plumbing. And we have to build a lot of scaffolding and framework for a lot of that stuff if we're building our own custom web APIs and dealing with security. And so one of the great advantages of Azure is a service called Azure Mobile Services. And what Azure Mobile Services does is just provides you a REST endpoint with APIs that are just available for you to store data, for performing complex logic in an API that you didn't have to build any of that scaffolding for. It's just there for you. And so one of the ways you can do this, it has a Node.js backend. It also has a .NET backend today. But you can just write some simple JavaScript inside of the Azure portal and return back data from SQL database, for example. And so this is a great way to build mobile applications, the backends for mobile applications, to provide users with the experiences they expect. And so users expect that their data be available from one device to another. They expect to be able to log in with Facebook on a mobile app. They expect to get push notifications when events occur. And Windows Azure Mobile Services or Microsoft Azure Mobile Services these days provide that sort of backend. And so we're going to dig in deeper to mobile services on May 14th in a follow-up webcast. So if you're interested in mobile services in depth, definitely check this out. If you want to get hands-on, I know in the Chicago area, Microsoft is in the month of May, kicks off tonight, I think, at the downtown.net user group. But in the month of May, they're doing a virtual hackathon, and mobile services is a component of that. If you'd like more information about that, feel free to send me a tweet or send me a message of some sort, and I can get you more info on how that will play out. All right, number 5, massively scalable web apps. This is one that I end up working with a lot. Large-scale e-commerce websites, just things at mass scale. It's difficult and very expensive to buy computing power for those peak demands. So think about it like, mountains and peaks and valleys. We have data centers that sit idle for a large amount of time because we know that maybe it's seasonally, maybe it's based on the time of day. We have these peaks where we have to have the right capacity to accommodate the demand. And so it's very expensive for us to buy the hardware that sits idle most of the time. If we don't anticipate those peaks, scaling quickly in our own data centers can be difficult and really impossible if there's just not enough hardware sitting around. So the way I like to think about it is Oprah. For me, if Oprah talked about my tech startup tomorrow, could I account and accommodate that load? And if you can't, that could be a problem if you have a high-growth startup that could go viral. It can be a problem just in your own data centers as well for enterprise applications. And managing large data centers can be extremely painful as well. And so with Windows Azure, with Microsoft Azure, we have capabilities to run applications out in Azure, e-commerce applications or whatever, massively scalable applications, and just turn a dial and scale it up or scale it out. And in addition to scaling up and out, scaling back in is also important. So that's that peak valley scenario where I may have computing power to deal with those peak loads, but I am paying for consumption here. And so if I can scale that back and just pay for what I need when I need it, that's a huge advantage for your finance folks. And the great news is it's the same technology we're using on premise, so I can deal with dev test pretty easily out in the cloud. I can do remote management with things like the REST API for managing my Azure applications. I can use PowerShell as well to automate and manage my applications as well. This is an area that is growing rapidly in Azure. So this is a relatively new service in Azure, new technology in Azure. When we started with Azure, we had a service called Access Control Service, and that allowed us to do things like federation with identity providers that had WS Star technologies implemented. And so things like SAML and WS Federation and WS Trust and all of those sort of technologies. And so it was basically a secure token service running in Azure is what ACS was. And that's a great service, but Azure Active Directory has evolved radically, and so there's been kind of this combination of what was ACS or what is ACS with Azure Active Directory to allow us to do things like sync our own Active Directory that's on-premise with Azure, and then do things like single sign-on across multiple apps. And so we could allow users to log in with identity providers like Google and Yahoo and Facebook, or custom identity providers or Active Directory on-premise with ACS. But now integrating that in with Azure Active Directory, I can also do single sign-in across apps like Box, or there's a large catalog of apps that I can do single sign-on with. And so this is a really interesting new sort of tool and technology with Windows Azure Active Directory, and it's certainly I think it's one that will be pretty popular in Azure. I know for myself personally, I use LastPass to keep track of all my passwords, but having a single sign-on or a password vault running in Azure would be extremely advantageous for me. So for those running SharePoint Server, you probably feel the pain when talking about SharePoint Server. Even if you love SharePoint Server, it still comes with pain. And the pain is just the large infrastructure required for a well-architected and well-designed SharePoint server. It's a complex environment with complex deployments. And that number one scenario of dev test really applies well with SharePoint Server as well. Because if I want to build up my own environment, historically what I've done is built up a lot of VMs in my own workstation, and so I have massive hardware to do this, and it's isolated then to me. But now I can share that with others or create my own isolated environment out in Azure with SharePoint Server for dev test as well. And so SharePoint is a great example. There's a number of ways to work with SharePoint. It might be, again, a situation where I have a virtual network bridging my on-premise data center, so I may want to keep things in my own data center, and that's a real reason why you would use SharePoint instead of SharePoint Online. So there definitely is a service in Microsoft's cloud inside of Office 365 that you can subscribe to a platform service called SharePoint Online. And platform services are certainly ideal if they meet your needs, if they provide the right capability and functionality that you need. But they can break down if you need advanced functionality, like I need to be able to integrate back on-premise to other data stores and other applications. And in a platform service, I may not have the ability to do that. And so running SharePoint in VMs in Microsoft's infrastructure services in Azure is a great scenario to use Azure. And so I can push that out to Azure. I can script out the deployment using PowerShell because it is a complex deployment, and automate and have an entire SharePoint environment running in Azure pretty quickly. And I could do things like, if I didn't want to bridge my own data center with a VPN tunnel using virtual networks, I could run Active Directory out in Azure as well. I could sync Active Directory between my on-premise network and Azure as well. So there's a lot of ways that you can plug in and use SharePoint Server in Azure, and that's a really common workload that we see. We're getting to really fun ones, so I love this one. This doesn't apply to everybody, but it applies to more folks than you might think just at first glance. Media encoding and streaming is a very complex scenario. Now, there are services that you could use today that are just cloud services, maybe even free, things like YouTube if you wanted to stream or upload videos and let people play your videos back, Vimeo, Ustream. There's a lot of services like that, but if you need your own platform for various reasons, maybe you want to do your own analytics or your own ad platform, or maybe you just don't want the branding in your video. Maybe you want to use it for video on your website, or video backgrounds, or hero images, that sort of thing. You can do that using media services. Now, media services in Azure, one of the things I really love about Microsoft and Azure in scenarios like this really shine is Microsoft has a ton of application servers and intellectual property that they're able to repurpose for Azure for cloud services. And so this is basically the Microsoft Media Platform running in the cloud, and certainly there have been adjustments to make it work well in the cloud as a cloud service, as a platform service. But they're repurposing their existing IP and their existing technologies as cloud services for us, so that we don't have to set up all that hardware. We can just subscribe. And so what this allows us to do is target multiple devices and platforms. We don't have to build the complex environments and make the huge infrastructure investments. And because of the global footprint of the data centers and the CDN nodes, we can stream globally very easily. And one of the best examples of this for me is NBC and the Olympics. In both London in 2012 and Sochi in 2014, NBC leveraged Azure for streaming all their media online. And we're talking about thousands of hours of video that they're streaming to ridiculous numbers of subscribers online to watch the Olympics around the world. And during the Build conference last month, NBC talked about the fact that they make a $1 billion investment on the Olympics, and they have to recoup that investment in 11 days. And so having any blip or issue with something like video streaming with ads in it is going to be a big issue for them in recouping that $1 billion. And so they depend on Azure to scale and stream without any issues their media around the world. And so that was a really compelling sort of case study and real-world experience using Azure Media Services. Number 9, we're coming to the end here. So SQL data. There are a couple of ways to use SQL data in Azure. There's a platform service called SQL Database. And SQL Database is a great relational database and a relational data store. It simplifies using and ramping up databases in Azure. You don't manage the servers, you don't manage the SQL Server through things like SQL Server Management Studio. What you do is ask for a server in the management portal and ask for a database in the management portal or via the APIs or PowerShell, and pretty instantly those things are available to you. And so this helps us get through some things that are difficult on-premise. So it's very difficult for us to build a highly available and scalable relational data store on-premise. Disaster recovery can be a little challenging as well. And rarely will our operations folks allow us to expose our SQL Server to the outside world. It's always sitting in a firewall and locked down. And I'm not suggesting that that's not the way it should be, but occasionally we may need to expose data to the outside world in some way. And so we have the ability to put data out in Azure in SQL Database. Beyond that, we could use SQL servers inside of virtual machines, and I can use those together. And so this diagram really shows that we can do things like have a SQL database, and I can have a 500 gig SQL database today. I can then, if I need to do things like analysis services or reporting services, I can connect back to that SQL database using those tools inside of a VM in Azure. I could also run the database on a VM in Azure if I wanted to as well. One of the advantages of SQL Database is it is highly available for us by default. We don't have to worry about configuring things like always on or mirroring or log shipping. Every time we store a piece of data in SQL Database, it's across 3 servers and it's highly available for us. And so SQL Database and SQL data is a common scenario for Azure. Number 10, also a fun one for me, is messaging. Messaging is becoming more and more important with occasionally connected devices, whether those are mobile devices like smartphones or things like sensors or kiosks. Communicating with those devices without a good messaging platform can be very difficult or impossible in some cases. And so messaging services in Azure bridge this. So things like publish, subscribe with topics that I can subscribe to in services like Windows Azure or Microsoft Azure Service Bus. The other scenario that's really nice with the messaging services in Azure is integrating back to our on-premises data center. And so sometimes we want a hybrid cloud with some things running in our own data center and some things running out in Azure. But we don't need to bridge that with a VPN tunnel, or we don't want to bridge that with a VPN tunnel. We just want an endpoint that can be consumed by clients out in the cloud, and maybe that is really sitting behind our firewall. And so there's a way to relay and kind of poke through the firewall with Service Bus, and it's a really slick service and a slick way to do this. But using port 80, your on-premise services can register with Azure, and port 80 outbound is generally open. Some scenarios, some data centers do not have port 80 outbound open, but generally it's open. And so then from the cloud, you can communicate back to Service Bus running in Azure or from third parties or other devices, and it will relay that back over that port 80 connection back into your own data center. So there's awesome messaging services in Azure, and we've used messaging services like this across mobile devices, so things like notification hubs that simplify push notifications in Azure to devices. Things like kiosks, where you may have tens of thousands or more kiosks around the country or the world. We've built solutions for kiosks to message back. Things like embedded devices, all great scenarios. So how much does all this cost? At the end of the day, it's got to have ROI. It's got to have a financial impact and benefit for us. And so one of the ways that you can determine what the pricing is like is by going to azure.microsoft.com, and then there's a link at the very top that's pricing, and it will pop up this nice pricing calculator that has a number of sliders, and you can just say I want one of these and one of these and two of these and 200 gigs of this kind of data, and it will compute out an estimated monthly cost for you using this pricing calculator. And so this is a great tool if you're just curious, what would this cost to run in Azure? Like what is the ROI for me? So check out azure.microsoft.com, and then there's a link at the top that's pricing. It's a great way to calculate that estimated cost. The other thing is, if you want to have as a point of reference these scenarios and the diagrams that we went through today, you can go to responsiveX.com/cloud-top-10, and that will allow you to download a PDF, a data sheet. It's a 2-page data sheet with all of these scenarios that we talked about today. So you can kind of take that home with you. And for those that are thinking about how do I get started, I might have scenarios that fit Azure, but I'm not really sure. I may want to learn a little bit more about Azure. How can you, Eric, or responsiveX help me do that? And so we have ways to jumpstart that with Microsoft. And just like your MSDN benefits, you also have benefits in licensing if you are buying your licensing on enterprise agreements, which large organizations commonly are. You can get, I don't want to say it's free consulting because it's not free, but Microsoft will pay responsiveX to come and work with you and to do things like an architecture and design session for a new app or an app migration to Azure, or training, or whatever it may be around helping you get started in Azure. And so we have structured consulting engagements that can be 3, 5, or 10 days based on your licensing benefits. And so if you are curious about how to get started and jumpstart your journey really to Azure and your journey to the cloud, we can help you with that. Feel free to reach out. We would love to explore whether you qualify and have these benefits or not.
Eric, thank you so much. This was just so informative and so helpful today, so we're just really appreciative of your time on this today, and so thank you. So with that, yeah, that is all the time we have today, and I just want to thank all the attendees for joining us today. I hope it was helpful as well. And Eric, again, thank you so much for taking the time to present today, and we want to thank our sponsor, Microsoft, for their support with this event today, too.